Welcome to a lesson with Dr. Powell. Let's continue the example from the last video. We're at X being this matrix right here. All right. Now, remember how we had X acting on this vector, and it looks like this, but you can also think of it this way. Let's think about this in terms of, right, you can plug it into this matrix, but also, how can you get this representation out by a matrix? You get it out by this matrix, XXX multiplied to this, right? That would work just fine. That means that this matrix is another representation of this matrix. Now, when you equate these, this does not mean that individual entries are equal to each other. This does mean, however, that individual columns are equal to each other. This column is represented by this by this by this. And we can easily see this if we think of this as being x times 1, 0, 0. Because if you plug in 1, 0, 0 into this matrix right here, think about that. That just picks out the first column here, which is 1, 0, 1. What does this mean? That means you pick out, so x times 0, 1, 0, well, that means to pick out the middle guy. That's the middle guy. What does this mean right here? And this means x times the 0, 0, 1, which means to pick out the last column. Well, indeed, the columns are the same according to that representation. So these are the same. And in fact, if you subtract column-wise, like column to column, you end up getting this matrix right here, which is representable as the 0 matrix right here. So this matrix right here, which we can think of as x times an identity matrix minus our original matrix A right here, this guy is actually equal to the 0 matrix. If A itself is that matrix is represented by X. Thanks for watching.